Hi, Calculus. Welcome to your notes video for the 7th of November, 2024. Today we are brought to you by sponsor of the book, Viktor Frankl's Man's Search for Meaning. Join Mr. Yako in the book club this January, Man's Search for Meaning. Your perfect January book. Also, shout out to When Bad Things Happen to Good People, Harold S. Kushner. Great book. As well, the Aldi version of the RX bar, because the body's a temple, but it's on a budget. All right, that's not bad. That's a good little jingle. Let's talk about e to the x. Definition of the number e. E is a number such that the limits as h goes to 0 of e to the h minus 1 over h is 1. Whoa! All right, so also, that's what e roughly is right there. So let's chat, guys. As we graph e to the x, we're graphing e to the x. And then we see the equation of the tangent line. So you got y equals e to the x, y equals 3 to the x, y is 2 to the x. So, e is pretty close to 3. So there it is. Let's look at 0. At 0, e is in fact, e to the 0 is 1. And the slope of the tangent line is also 1. And then as we just keep going, folks, when I have x, e to the x. My slope is always e to the x. So the slope of the tangent line is always what the y value is. So the slope of the tangent line is always what the y value is. There's some more proofs online. All that's to say, folks, and we're not going to solve that. Algebraically, I don't think. Anyway, the definition, the derivative of e to the x is, in fact, e to the x. The derivative of e to the x is e to the x. Might show you something else here when I see you again on Friday. But there it is. Derivative of e, that's your first special one. Derivative of e to the x is e to the x. All right? Interesting. Now, until we get the chain, there's something a little more there, because that's x, that's just 1x. What's the derivative of x? Well, it's just 1, so that's very important. All right, so we're going to have differentiate the function for several of these. Differentiate the function. All right, so you got g of x is equal to 7x squared minus 3x plus 12. Bring down the power. 1 power less. X is 0 is 1. This is simply 7 over 2x minus 3. All right, pause this whenever you need to. Going to try to make this video relatively quick. Y is equal to some constant. I actually don't. I think we're fine. That's what your book had. Anyway, bring down the power. So I put the c on the outside. Bring down the power, 1 power less. There it is. Y to the negative 7th needs to go down south. Y to the 7th. Y prime, folks, Y prime. Oh my goodness. All right, so first off, this is 3 to the x plus 4. So this is x to the 1/3 power, but it's down south. If it's down south, it's x to the negative 1/3 power. See, so the harder derivatives from section 3.1. All right, so this is simply 3 times what's the derivative of e to the x? What's e to the x? I'm going to bring down the power 1 power less. Okay, so x to the negative 4/3 means x to the 4/3 is down south. So is 3. 4 is the only thing up north. All right. Let's take a look at 4. So again, this is the question. Again, pause if you need to. 1 plus 16 t to the 3rd over 4 t to the 3rd. You're going to cube this, 64 t to the 3rd. So let's break this apart. You don't know the quotient rule. You don't want to do the quotient rule here. You're going to say 1 over 64 t to the 3rd plus 16 t to the 3rd over 64 t to the 3rd. So this is going to be 1 over 64. T to the 3rd down south means you have t to the negative 3rd. And then you have a quarter. Okay, what's the derivative of a constant? 0. So you're going to bring down this power. Negative 3 over 64. And t to the negative 4th. 1 power less. 1 power less. All right, 5. Look at 5. You're foiling something. So, our little rule works. I'm going to take this first term. I'm going to square it. The inner product is 2x to the negative 1st, so I double it, 4x to the negative 1st. Then I'm going to take this and square it, multiply the powers. All right, the derivative of constant is 0. So this 4, I'm putting the 4 on the outside here. But I could just like bring down the power. 4 times -1, 1 power less. Bring down the power, -2, 1 power less. All right, so 4 times -1 is a -4. X to the -2nd is x squared minus x to the -3rd down south. Let's go. About 4 or 5 pages here, so we want to keep going. Look at 6, easy peasy. F of t is equal to 2t to the 3rd minus 6t squared minus 4t. Bring down the power, 1 power less, about as easy as a derivative can get. All right. Oh, look at 7. Look at 7. So if we don't know the chain rule, which we don't, how will we do this? First off, let's square it. Okay, so what did I do? I did 2x minus 3 squared times 2x minus 3. Square 2x minus 3, get that multiplied by 2x minus 3. I'm going to do a little distribution. Cleans up this way, I believe. That's f of x. Now, some students want to stop because they've done a lot of algebra just to get that, but that's just to get f of x. Now it's easy. Power rule, bring down the power, 1 power less. Bring down the power, 1 power less. All right. Okay, so f of x is equal to 4x squared minus 3 over x. 4x squared, so that's 4x to the -2nd minus 3x to the -1st. Bring down the power. -8. X to the -3rd. 1 power less. Bring down the power. 1 power less. All right, so I brought down the power. It's going to be 4 times a -2. I just showed it in a different way. 4 times a -2 is a -8. 1 power less is x to the -3rd. Put it south. Negative times a negative is a positive. Bring down the power. So -3 times a -1, 1 power less. There it is. Okay, find the equation line, the equation of the tangent line to the curve at the given point. Y is equal to x plus 2 over x at the point 2, 3. Plug in 2 for x, you get 3. Well, first off, what's the derivative? Well, first, like this is y is equal to x plus 2x to the -1st. So what's the derivative of that? All right, what's the derivative? What does that matter? We'll just see here. Derivative of x is 1. Bring down the power. 1 power less. So that's the derivative. Guys, the slope of the tangent line is the instantaneous rate of change at that point, which means I can get the general derivative, 1 minus 2 over x squared, and the slope is simply the derivative evaluated at that x value. So I find the derivative and I plug 2 into the derivative, so it's going to be 1 minus 2 over 2 squared, which is 1 minus a half, which is a half. So the equation of the tangent line is y minus the y value is equal to the slope. It's 1/2 times x minus 2. So we simply need to find the generic derivative and plug that in for x. Now, on your Chapter 2 test, just like you did, like you had today on your quiz, today being when I made this video, you have to show using the limit definition. Using limit definition. This is not the limit definition. This is Chapter 3. Your exam next week is over Chapter 2. All right, so this is going to be x to the 1/4 minus x to the 1st. So I'm going to find the derivative of this. Bring down a quarter, 1 power less, minus derivative of x is 1. Because you're going to plug numbers in, I think you want to have this negative exponent go south. I'm only plugging 1 in, so I shouldn't get in that much trouble. If I plug 1 in for x, again, the slope is the general derivative evaluated at that x value. Plug 1 in for x, and you get -3/4. So y minus the y value is equal to the slope times x minus the x value. Now remember, folks, you have a homework set number 4 due on Friday. Due on Friday. Okay? So let's turn that in. Giving a lot of time for that homework set. Y is equal to a quarter x minus x to the 1st, which I already did. Sorry. All right, need to... Boom. Okay, y is equal to 4 to the x plus 2e to the x. What a curve here. Bring down the power, 1 power less. 2 times the derivative of e to the x is e to the x. That is nice. The slope is the derivative evaluated at 0. This is going to be 0, but 2e to the 0, folks, is e to the 0 is 1. 2 times 1 is 2. y minus the y value is equal to the slope times x minus the x value. And here's a few more. And that'll be good. We'll finish 3-1. We could be finished. We'll get into the product rule next Thursday and Friday. All right, so example 12. Same thing, equation of tangent line to this curve at this point. So y equals x minus x to the 1/2. Bring down the power, 1 power less. Bring down the power, 1 power less. Minus 1/2, that's x to the 1/2. I'm going to plug 1 in for x. The slope is the derivative evaluated at 1. I'm going to plug 1 in for x. I get another half. Y minus the y value is equal to the slope times x minus the x value. All right, so example 181 here. All right, 181 for 49 says the equation of motion of a particle is that is the equation of motion for particle. That's position. S is position. Where S is in meters and T is in seconds. Find the velocity and accelerations as of functions of T. Well, velocity is the derivative of the position function, and acceleration is the derivative of velocity, which is the second derivative of position. So velocity, I simply take the derivative of this, 3x squared minus 3. It's velocity. What's acceleration? It's the derivative of this, 6t. B says find the acceleration after 2 seconds. We'll plug 2 in for t. It is meters per second squared. It's set in terms of meters and seconds. All right, C says find the acceleration when velocity is 0. All right, so if velocity is 0, then I'm going to set 0 equal to the velocity equation. I get the time, you're going to have t squared is plus or minus 1. So I set, again, velocity equal to 0. I'm going to get 3t squared is 3. T squared is 1. T is plus or minus 1. This is time. It has to be positive seconds here. So I'm going to then plug 1 in for t and acceleration. I get 6 meters per second. And then 50, which is going to end here on 50. The equation of motion for a particle is this in black. That is the equation of motion of a particle. Find velocity and acceleration as functions of t. That means find v of t and a of t. Bring down power, 1 power less. Bring down the power, 1 power less. Bring down the power, 1 power less. Bam. Bring down the power, 1 power less. Bring down the power, 1 power less. Bring down the power, 1 power less. And then find the acceleration after 1 second. A of 1. You get 2 meters per second squared. All right. Obviously, if you need to, finish homework set number 4 for chapter 2. Study. We're going to talk Friday all about the exam, but study. You guys have been given the questions. You've been given the work and the answers. Let's go. There's the bar. You can reach it. You can do it. All right. This is Yak Math Video, signing out.